asking your questions. There'll be answers given to you throughout as well by our team. At the end of the session, there'll be a question and answer session where I'll be answering some of the questions as well. I'll be pulling some of those out. Also, I'd like to remind you that at the end of the webinar, in your web browser, there'll be a pop-up. It's not spam, it's a feedback form. And if you complete that feedback form, we'd be happy to give you a US $25 AWS credit for anyone who completes that form. So that's a great way to get going and get started. So with that, let's start our topic. So today's topic is designing for failure. Now, there's a bit of a premise that we should share firstly, which is that when you think about IT, everything fails all the time. And our CTO, Werner Vogel, said this many years ago now, and he's very correct, is if you look at any large or even small-scale operation, there'll be components that fail. It could be a hard drive, it could be a server, it could be an entire network segment. There are many and varied ways in which things can fail. And the challenge is that when that failure occurs, we often get asked questions. And the first question is asked is, why didn't you design for it? Your boss may ask you this question, your investors, your customers, when they can't access the particular service that they want, will ask you these questions. And so this is why the rule of design for failure and nothing will fail comes into play. And really it changes the way that as an architect and a software designer you think about infrastructure, you think about IT, you think about design. So a bit of an agenda for today's session. We'll be talking about the need to use multiple availability zones and what they are. We'll talk about maintaining your application state in a highly available way. I'll share with you some design principles about designing for failure. We'll talk about how you do recover from failures when they become significant, and also some testing elements as well. So let's start with availability zones. So a bit of a refresher. The way Amazon Web Services is architected is that you have a choice of a number of global regions. Each of these regions operate independently. So as a user, you get to choose where you locate your compute, where you locate your storage, how you do things, and every command has a parameter which is the region parameter, and that specifies where that operation takes place. The nice thing is that everything works the same in all the different regions, so your skills are very portable. You can deploy your application globally if you want, but it also gives you a great deal of control around localization. So as you can see there in the APAC region, we have obviously Sydney, we have Singapore, we have Tokyo as well as our regions around here. Now within each region, there are 2 or more availability zones. An availability zone is a geographically separate cluster of data centers. It has its own set of power feeds, its own network connectivity, it's in a physically separate location, they're located in low-risk areas as you would imagine, and they're interconnected with low latency network links. So what this means is that conceptually you have really access to multiple data centers if you think about it from a conventional perspective, where you can deploy your resources. This physical separation is very important because it allows you to define failure domains. It means that you can deploy your application across multiple availability zones, and should an availability zone become unavailable for some reason, your application, if it's correctly architected, will still function. Now, the good news is that you don't have to architect everything to use cross-availability zones. Many of the AWS services already do this for you. So you can see on the left a sample of some of those ones that already by default span across availability zones. So for example, the simple storage service, when you store an object in S3, you point to a simple endpoint and do the request to store that object. That object will be replicated across multiple nodes, across multiple availability zones within the region for you. This will happen behind the scenes. You don't have to manage it. You don't need to worry about it. However, there are components where you do need to think about it. So for example, with the EC2, the Elastic Compute Cloud, you choose where your compute instances are deployed. So if you're designing a fault-tolerant architecture, you'd want to evenly deploy your EC2 instances across multiple availability zones. Now you can use tools like Autoscale to make this happen on a policy basis and happen automatically. Similarly, things like virtual private cloud, you need to define them to span the multiple availability zones to provide you with that resilience. So a foundational concept there. Now what about state? State is usually a single point of failure. Now a quick definition. State is really about what your application is doing at the time when it's interacting with a particular user. So it could be tracking where a particular person is up to in a workflow. It could be what information they've entered on a particular website, etc. There's a variety of uses for state. And state typically becomes a problem because it has to reside somewhere, and so we have to protect it very carefully. Now, in a simple case, you can store some cookies in a browser. More often than not, you'll have some sort of session database which stores information for a period of time. You may have a memory resident session manager, so this may be instead of or in combination with the session database. Or you may even have a framework provided session handler. So many frameworks build in the session handling capability and then store it somewhere. So the somewhere is the important consideration. Firstly, this store of state needs to be performant because obviously every user is going to be interacting with this component. It needs to be scalable because we don't want the store of state to become the choke point for the application. And it needs to be reliable because if our store of state goes away, then obviously our application will cease to function irrespective of those other components. So what do you build your state component on? Well, the answer is you want to choose as highly available service as possible that will allow you to have increased reliability and very quick recoverability. So we're going to walk through three options. These are not the only options, they're just some fundamental options that you can think about. One is Elasticache, one is DynamoDB, and one is Amazon RDS with multiple AZ. So what is Elasticache? Elasticache makes it very easy for you to deploy an in-memory cache in the cloud. And essentially this is Memcached, which is a very common open source platform for storing key value pairs. Elasticache allows you to create these clusters of nodes in a very automated fashion. It means that you get very fast response time when you're querying that cache. And it also handles some of the undifferentiated heavy lifting of replacing nodes, naming them, etc. But the thing to remember with Elasticache is it is an in-memory database, so it is not persistent anywhere. So there are a number of strategies you can use in this case. You could create multiple Elasticache clusters in multiple availability zones, and when you're updating your cache, you could update both locations in the cache. That way, in the event of a failure of one side of the cache, the other side of the cache still exists. Or you could choose to have Elasticache simply as a pure caching layer in between a more persistent layer. Again, a number of options there, but certainly something to think about depending on the use case. A second option is DynamoDB. Now, DynamoDB is one of our fastest growing services, and it's basically a managed NoSQL database, which means that the schema model is very straightforward and very simple. It's very, very performant. So it's built on solid-state drives, which means it's very reliable from a performance perspective. We get single-digit millisecond latencies. You also have the ability to dial in the amount of provisioned throughput you'd like for your database. So you can specify how many reads, how many writes you want it to cater for, and it will reshard the database in the background to cater for this. Any of you who have worked in highly scaled environments will know that this sharding and scaling can be quite a challenge in many instances. You have unlimited storage, you have no downtime, you have a highly available system, which are very good features for a store of state. Interestingly enough, if you're a user of ASP.NET, that actually has a plugin directly into DynamoDB, so you can use it as the session store for that particular Microsoft framework. Another option, if you're more familiar with relational databases, is to use the relational database service. This gives you a managed endpoint to store a variety of database engines, including Oracle, MySQL, and SQL Server. It's very, very easy to deploy, simple to operate and scale up. It's very reliable and very cost effective. In fact, it's one of the most popular services that my customers have because it just makes life so much easier when it comes to creating a database. Now, obviously, this database needs to be resilient if this is where we're going to have some sort of state stored. So we have the option to create multiple AZs, and I'll talk about that more in a moment. We also take place automated backups. This means that backups can take place and allow us to recover up to anything including the last 5 minutes of data automatically. We can also maintain up to 35 days of backups automatically and unlimited length of time backups as we so choose, all stored on S3. The other nice thing is that we can easily replicate the infrastructure. So rebuilding a database from a snapshot is trivial as point and click, rather than having to do an extended installation process. Again, if we're talking about a highly available and fault-tolerant design, we would want more than one instance of the database. So with RDS, when you're using MySQL or Oracle, with just one click, you can have a secondary node being synchronously replicated to in an alternate availability zone. The failover is handled automatically for you, and you could even, in the MySQL perspective, promote your replica to test the failover process as well. So an example of a customer who has to deal with large workloads and who has to deal with a very strong audience wanting to watch things in real time is Vodafone, which is an Australian telco provider who stream the cricket during the summer. And they're able to stream over 10,000 simultaneous customers for their streaming services. And what this has provided to them is a very scalable, robust, and easy to deploy application for what is a very elastic use case. So what about some design principles? Well, there are a number that we can think about. Now, one of the things to think about is firstly separation of components and making them more granular. So certainly those session stores that we spoke about before could be broken up into multiple sharded copies thereof, so that you can have multiple copies, you could break them up across multiple pieces of hardware. You can again reduce the risk of failure for any particular component. But there are some others that I'd like to share with you as well, and the list is really endless, but these are some fundamentals that really need to be well understood. The first is automation. The second is the concept of loose coupling. And the third is the creation of what are called self-healing systems. So let's walk through those. One of the benefits of working with AWS is you have complete programmability of the platform. Everything is exposed via an application programming interface, an API, which means that doing something is simply a web service call away. Now this could be wrapped up in a software development kit, it could be a command line call, it could be a GUI interaction, but fundamentally underneath, everything is driven through the API, which means that you can automate all of those steps. Human beings need not be involved. Now, we provide a number of different tools that suit different purposes in this case. One is called CloudFormation, which allows you to automatically build entire stacks of an application, be it the load balancer, the web servers, autoscale groups, database servers, application servers, security groups, etc., etc., etc. Elastic Beanstalk, which allows you to automatically deploy things like .NET, Ruby, Java, Python, Node.js, etc., to a pre-built platform for you, so that you don't have to worry about how to build a auto-scaled, highly resilient application. And then there's OpsWorks, which focuses more on the continuous deployment side of things, of rolling code out across multiple layers of an application. But the key with automation is it means faster recovery from failure and tolerance and expectation of failure. Consider for a moment a set of web servers. And this set of web servers is positioned behind a load balancer. If we have sufficient automation whereby when an autoscale event detects that a node has failed in that web server farm, the node itself can spin itself up, a brand new one, load any source code and packages that are required, load the configuration, register itself with the load balancer and bring it into service without anyone being involved. That creates a very failure-tolerant environment. It means that as an administrator or a developer, you get to sleep soundly at night knowing that your website will still be working because things are taken care of on a policy basis automatically. You should not need human beings to implement software to get new systems up and running. This should all be happening in a kind of a bootstrapping approach at startup. Now, loose coupling is another very important concept. It basically allows you to firewall or protect one component from another by decoupling these components. Many people start with very tightly coupled applications where one thing calls another component in real time. It has to receive a response. It has to service it in a particular time frame, or things tend to break up the chain. Loose coupling turns this on its head and says each component is an individual and discrete service-oriented provision that gets called with a well-known interface and will return a well-known response. But it may not do it in real time. So what's an example of this? An example of this is using this simple queuing service. Simple queuing service is a reliable, very scalable hosted queue for storing messages. So it is persistent. When you write to the queue, it gets stored in multiple places for you, spread across those availability zones, as we spoke about before, and then can be pulled from on demand. So we could have a situation where we choose to have a receive queue, a transcode queue, and a notify queue, where each of these processes are separate. So let's say we have someone uploading a movie. They upload the movie, and we now place a message on the receive queue saying, hey, we've just got a movie, it's stored in this particular location. Then we perform any activity we want to do there, and then say, okay, it's ready to be transcoded. We put a notification on the transcode queue. Something is listening to the transcode queue, and we'll perform the transcoding when it's required. Excuse me. Now, one of the benefits you have here is you may choose to say, I don't want to perform all the traffic, all the transactions on an as-needed basis. I'll do it on a periodic basis when my queue is full enough for what I need to do. Conversely, if there's an issue with one of the components, maybe your transcoder is failed or is not working for some reason or is undergoing an upgrade, you can buffer the traffic that's coming to that transcoder in the queue. At such time as you have that service up and running again, the queue will feed the work through that transcoder again. In this case, at the end of our process, we notify our customer that things are ready as well. Now we can get far more sophisticated if we so choose. Using the simple workflow service, we can create very intricate rules around the overall process we want to go through. So in this case, we're receiving our video, we're checking that the length is appropriate, we're checking that it's not spam, we're transcoding, then we're publishing. So we're doing some more intricate steps, some more complicated steps as we go. And what about self-healing? So this is where we combine a number of components. We combine the concept of real-time monitoring, of bootstrapping our application, so making it start itself, and auto-scaling to create a system that's self-healed. So the concept of bootstrapping is all about a node being able to self-identify at startup. It can say, what am I and what should my role be? What software needs to be installed onto myself? What configuration should I do? Autoscaling leverages that capability by saying, I can set policies around a particular tier of my application, typically the web tier or the application tier. And I say, I want to run a certain number of nodes within that tier at any one time. And based on prevailing conditions, I may want to expand the capacity of that tier or reduce the capacity of that tier. So it could be when I'm experiencing heavy CPU utilization, or it could be when I'm experiencing heavy network load. Conversely, it could be time-based. It could be I'm going to be running a marketing campaign, it starts at 7 p.m. tonight, I need to triple the size of my web farm. Autoscaling will do that automatically by initiating the startup of a number of nodes. If those nodes can bootstrap themselves, suddenly you have a very effective set of compute resource that can tolerate high workloads and failure of nodes as well. Because just like we can grow and shrink, we can maintain a steady state. So let's say we have a web farm with 4 nodes and one node fails. The rule says you must have 4 nodes. So autoscaling will say, I need to replace the failed node automatically and continue trying to do that until such time as things are up and running again. So let's have a look how this looks. Here's our application. We have 4 web servers behind a load balancer. They are belonging to an autoscale group. If a particular node fails, autoscaling will automatically start up a replica node, bring it into service, and register it with the Elastic Load Balancer. The process for this typically takes a few minutes depending on the startup time of your node, but this means that you can be back in action very quickly. Now, the important thing to remember in this particular architecture is that whilst that node had failed, you were still able to handle traffic using the other nodes. The replacement node simply means you retrieve the same level of capacity that you had before. So the trick here is not to deploy to one node in one availability zone, but multiple nodes in multiple availability zones. So an example of an organization using things like the simple queuing service is a company called 8K Miles. And they provide a distributed development platform that allows developers to get access to systems that they need when they're building things. Now, one of the interesting use cases they've done here is they've used the simple queuing service again as that buffering component between creating events and doing things like creating development environments and the like. So they can provide a very efficient and effective console experience for their customers and provide a level of resilience that is very impressive. So what about disaster recovery? So the question is, well, something has failed, and maybe it's failed monumentally in a bad way. How do we get back quickly? Because maybe we couldn't think of every single eventuality and we got caught out. So we need our secondary approach. So backup and restore on AWS gives you some options. And it gives you options not just for applications that are running in the cloud, but applications that you're running on premises as well. Because what you get with the storage capabilities that we have available are durability and fast recovery without the management overhead. And the 4 storage options I'd like to speak about today are the Amazon Simple Storage Service, the AWS Storage Gateway, the Elastic Block Store, and finally Amazon Glacier. Simple Storage Service, which is probably one of the best known services that we have and certainly one of our oldest running services, is beneficial because it gives you unlimited capacity for your storage. So you can store as much information there as you like, paying as you go. So you only pay for the storage that you consume, which makes it very cost effective. It's also very efficient because, as we mentioned earlier, all the objects that you store in S3 are automatically replicated around the availability zones in a particular region. You can, of course, choose to replicate your data to multiple regions as well. You can either do that at write time, so you can write to 2 locations simultaneously, or you can use the copy API to copy data around as well. This provides a very robust location to store data for long periods of time. Interestingly enough, it also provides a lifecycle policy capability, which allows you to delete objects after periods of time based on rules that you set. So you may say, I want to store backup copies of information onto S3 for 90 days, but after 90 days, please go ahead and delete them for me. Another alternative is the use of the storage gateway. This is a really useful capability when you have on-premises infrastructure that you'd like to back up to Amazon. It runs in a virtual machine. It can run in VMware or it can run in Hyper-V. And it provides a gateway over which data is encrypted and sent directly to S3. Once it's in S3, you're also able to recreate those volumes in the Elastic Block Store and mount them to drives to your EC2 instances. So you can use this as a transport mechanism to send data off premises very, very effectively. Simple to set up, self-service, very cost effective. The Elastic Block Store itself is also an interesting capability. So Elastic Block Store acts as volumes for your EC2 servers. It sort of looks, reports, and acts like a normal volume would, anything from 1 gig to 1 terabyte of storage per volume. And you mount those volumes to your EC2 instances. The interesting thing is that the life cycle of an EBS volume is separate from the server it's attached to. This is very important because it means if there's a failure of a server, for example, in this architecture we only have 1 web server. Maybe it's a very small application. We don't want to build in all the redundancy in the world. We're just going to have 1 server with an Elastic IP. If this particular server fails, we can start a new one, attach the Elastic IP, and also reattach the EBS volume that may have had important application data directly to that instance. That way we'd be up and running straight away. So in this case, we haven't had to do any restoration. There's no restore from backup that's taken place. We've just got going straight away. If we want to protect the data that's on that EBS volume even more so, we can also, of course, snapshot that volume. And that snapshot will be stored at block level in S3. It will also allow us to store incremental changes to that snapshot over time as well. One of the other new capabilities that we've recently announced is the ability to replicate EBS snapshots between regions. So for example, you may have your primary storage of data in Tokyo, and you may choose to replicate it to Singapore. And as I mentioned, those snapshots get stored in S3, which means that they are very resilient and reliable, and also very, very cost effective. Remembering that we don't store all the data on the snapshot every time, it's only the change data that gets stored. So if you have a 10% rate of change, you'll only be storing 10% of the data. Because it's S3, you'll only be paying for 10% of the data as well. And finally, Amazon Glacier. Amazon Glacier provides you with a very durable and very low cost storage environment. So for example, in US East, the price is 1 cent per gig per month, which is very cost effective for storing data that is again replicated multiple times around the region. The difference between Glacier and S3 though is that whilst S3 provides you with immediate recovery of data and recall of files, Glacier, as the name suggests, gives you a 3 to 5 hour latency in getting those files back. So this is useful for archival of files that are long-term storage that may need to be kept for long periods of time, but you don't need back straight away. Another interesting point to remember is that the lifecycle policies I mentioned that work with S3 also work with Glacier. So you can set a policy where you back up to S3 in the first instance, and then after 90 days those files get moved to Glacier. You still access them through S3, and they're very easy to recall as well. So who's doing this at the moment? Well, a number of different companies do this for different reasons. So Lifeline, for example, they do disaster recovery for highly regulated industries, and they dramatically reduce the cost of vaulting and the DR implementations by moving to AWS. Sage deployed their Oracle e-business suite and the dev test on us as well. So this was again a way of being far more responsive to what the business needed and being more cost effective at the same time, which is often a challenge for many organizations. So let's move on to our final item of the day, which is testing tools. It's important to test. In fact, I think on our survey that we did just before, 9% of people weren't even sure, which tended to indicate they haven't tested or they were brave enough to admit that they hadn't tested. Testing tends to be viewed as a high-risk add-on, and really it needs to be fundamental to what you do. Probably the best known or most publicised version of testing out there is the Chaos Monkey and the Simian Army from Netflix, which is a tool that they've open sourced. And its job is to go around turning things off, doing those arbitrary things that as human beings we don't like to see happen, but realistically we know will happen over time, because remember, everything fails all the time. Now, you can either choose to be a victim of the failure or get ahead of the failure. And by testing proactively, you get to see what you haven't designed for and start working around those particular problems. This can also be used as a very powerful message to the business. In fact, I've seen customer demonstrations that have been done internally to senior management teams where they've run Chaos Monkey on systems that they've created and said, hey, look, we built this to be resilient. Here are the kinds of failures we can cater for. And as you can see, the business-facing component of the application is still operating, is still running. And these executives were blown away to see this capability because they knew that in a traditional environment when failure happened, they got a phone call. Another really interesting testing tool that you should be aware of is something called Bees with Machine Guns. Certainly a name that you won't forget in a hurry. And this is a tool that was created by the Chicago Tribune in the US, and they open sourced it. And it basically allows you to volume test your application. So it generates significant amounts of load. But it does this by using micro instances in the AWS cloud. So again, this is a tool that can be used both for your cloud-hosted applications and internal applications. Because what this lets you do is synthesize large amounts of system load, which is often a challenge to do in an effective way. By seeing how your application performs under this large amount of load, you can see if there are any obvious breakpoints. You can then take it a step further and start taking components out of service. So you can imagine combining the use of Bees with Machine Guns with Chaos Monkey to put a system under load and then start failing components. If you've built a loosely coupled environment, this is where you should see the benefits of that loosely coupled environment. So for example, seeing queues start to grow in length as particular services are unavailable. If you haven't built a loosely coupled environment, this is where you'll see failures taking place. And you'll start to see an end user degradation in performance or a loss of a service altogether. So Netflix, when they sort of took this approach, they came from a very traditional data center-centric application architecture. And they changed their design capabilities, they changed their approaches, and they changed their platform. And now they've been able to increase their reliability by an order of magnitude. They've significantly changed how they operate. Now, this is always a continuous improvement. This is something that organizations work through on an ongoing basis. So it's not a situation where you're ever done. But you're able to make the environment better, more resilient, and more resistant to failure as you go along. Now, I'd like to make you aware of a few events that we have coming up before we wrap up. Firstly, we've opened our expression of interest for our Singapore Summit. So this is in July, on the 18th of July. Our keynote speaker will be, of course, Dr. Werner Vogels, who, again, has many interesting views on this topic. So you can see the registration link there down below. We're also thrilled to announce 3 events in India, June 25th in Mumbai, June 27th in Delhi, and July the 5th in Bangalore. Again, visit that website to pre-register your interest, and we'll be thrilled to keep you up to date with what's going on with those events. As I mentioned earlier, after the Q&A, there'll be a survey that pops up at the end. Please take the time to fill it in because it helps us understand how to better serve you. And in recognition of you spending a few moments of your time, we'd be thrilled to give you $25 of AWS credits. They can get you quite far. You can do quite a bit of experimentation with $25 used in an effective way. Also, I'd like to invite you to subscribe to the Amazon podcast, the AWS podcast, which you can visit at aws.amazon.com/podcast. This is typically a weekly podcast that we release to keep customers up to date with what's going on in the world of AWS. It's often an easy way to keep across all the changes that take place. So now what we'll do is we may look at some questions and see some obvious ones that we need to answer here. So let me just look it through here. Bear with me for a moment. So the question is, I've not seen the option to include a server across availability zones in a single load balancer. When I go to select the load servers to be included in a load balancer, it doesn't list the servers in a different availability zone. So when you create your elastic load balancer, you need to specify which availability zones it should be looking for servers in. So when you create your ELB, you'd also specify the availability zones that the ELB will be referring to as well. Now, if you've gone ahead and created an ELB and it's not configured the way you want, don't lose heart. It's very simple. You just create a new one and replace the old one, rechanging the DNS entry that you made. There's a question, can we use S3 for live feeds of XML files and CSV files? Well, S3 is a real-time platform, so as quickly as you can write and read, you can use it. So one of the things we recommend when using S3 is to use as much parallelism as possible. So you may use things like multi-part upload. You may have multiple applications pulling from that data at the same time as well. A few more questions here. Just going through. One of the questions is, if AWS provides for high availability, why do we need a DR setup? Really it becomes a case of risk mitigation. And this will depend on the risk modes that you are trying to cater for your particular application and for your business. So for example, if you've got your application appropriately architected so it can operate across multiple availability zones, then really what you're trying to mitigate in terms of a multi-regional model is to say, well, if we lose access to an entire region for some reason, and I can't think of what that would be, maybe a significant network event that affects a whole country, that might affect us from that perspective. That said, it's always important to keep some form of disaster recovery. It might not be a live setup, and it might not be an active-active type thing. It may simply be every couple of hours or at the end of every day we take a copy of all the relevant important data and we move it to some other location. So it could be another AWS region, it may even be back to our own data center, it just depends on what you want to do. It just gives you that choice. At AWS, we're very focused on giving customers as much choice as possible to deploy the way that you would like to deploy. Now, there's one question about what happens when we shut down an EC2 server that has an EBS volume attached. Well, there's two choices you have when you terminate an EC2 instance. You can terminate the attached volumes automatically, so you don't have to clean up afterwards. Pardon me. Or you can keep those volumes around automatically and just manage them yourself. So you have the choice of what to do. Just looking for some other questions here. Just bear with me. One of the questions was, does RDS support Oracle RAC? So the answer for that is no, we do not support Oracle RAC. We do support synchronous replication between multiple nodes though, but it will still be a single node of the Oracle database. You can make that as big as you like within the bounds of what RDS supports. For those customers who do still want to run Oracle RAC for some reason, they may have a need particular because of an application dependency, etc. One of the solutions around that space is to use what's called Direct Connect. Direct Connect allows you to have a private network connection from your site into an AWS peering point, a point of presence, which then cross-connects into the AWS network. This means you can have very high bandwidth, very low latency, and you can connect back to your database very easily. In fact, I believe in the US there's a company that offers this as a service specifically for those customers who want to run the bulk of their applications in Amazon and have some reliance on Oracle RAC as well. Another question which relates to that is connectivity options available for AWS to connect to a company's data center and best practices. So a number of different options there. So firstly, you can use VPN, so virtual private network. This can be a hardware VPN connecting to a router, or it can be a software VPN. You can choose what you'd like to deploy. We support both. And that uses obviously internet connectivity. If you want something more substantial in terms of bandwidth or more controlled in terms of quality of service, then that's where Direct Connect comes in. So again, Direct Connect is a private network connection. You can have increments of 1 gig or 10 gig. You can have multiple links. You can share the same link across multiple virtual private clouds and also between multiple accounts if you like as well, using VLAN tagging. So this gives you a very efficient way to connect your on-premise resources with your cloud-based resources as well. It's becoming a very, very popular approach. So just going through some other questions. So one question was, when would we use Elastic Beanstalk rather than using EC2 and Autoscale? And the nice thing is it's not an either or, it just depends on what your focus is. So Elastic Beanstalk is really a tool. It's a free tool. It doesn't cost anything to use. You get charged for the resources you consume when running applications in Elastic Beanstalk, but the service itself is free. And it's designed to provide an easy framework for application developers to deploy their applications to the cloud in a robust fashion. So let me give you a Ruby example. So I was working on a project recently where this was the case. You create a Ruby application. This was a Sinatra one, providing an API endpoint. And basically, all you do is you configure your Elastic Beanstalk application to say what you like. You know, I'd like a deployment on a 64-bit instance of this particular size. Elastic Beanstalk then takes care of creating the load balancer, of creating the autoscale group for you based on the parameters you set, so the minimum and the maximum you want. It can also set up a relational database service database for you and all the other components. It will also then, excuse me, deploy the application to the server and redeploy the application to the server as necessary. So for example, in the Ruby case, the deployment is as simple as typing in git space aws.push, and it will push the latest version of the code out to those servers automatically. So it's not a case of using one or the other. It depends on what your focus is. If you're a development-focused person, so you're sitting in Visual Studio all day or Eclipse, you'd use Elastic Beanstalk. Just going through some other questions as well. There's lots happening here. So there's a question about, is there any risk if we're using loose coupling but the queue is in the application as against one that's using a separate queue itself? So really, again, this depends on the architectural design principles in which you built that queue. There are many open source and third-party queues that are also excellent solutions. You just need to make sure that they will scale, that they do not in and of themselves present a single point of failure. They're the main things that you need to worry about. Then other than that, you're just looking for the functional components that you need. Simple queuing service is one available approach for you. You don't have to have that though. So a question here, instead of having the entire design replicated in multiple availability zones, can I have one server in one zone and a second web server in another zone? Absolutely. So you don't have to duplicate your entire design across the availability zones. You can have part of it in one zone, part of it in the other zone. So say, for example, you have a web farm of 6 web servers. You can have 3 in one zone and 3 in the other zone, and the elastic load balancer will load balance across them. Now you still need to think about capacity, and you still need to think about what happens if you lose that other half. You want to make sure that autoscale will grow, or you may want to have that in there as well automatically. There's a question here about RDS multi-region replication. Is it on the roadmap? Certainly we love to listen to customer feedback about what they'd like to see. This is an idea that's come to us many times, so certainly it's something we're looking at and considering. There was a question about what's the difference between Glacier, or the price difference between Glacier and S3 Glacier. So the nice thing is that the pricing when you're storing on S3 is the S3 pricing, and then when the object is moved to Glacier, you'll pay the Glacier pricing for that object. So basically the volume of data you're paying a particular price for will change depending on where the tiering is. Just looking for another few questions that are more general for people. So there's a question about high-speed transfer of data between EC2. Is it better to use EBS or S3? Another of the wonderful it depends type answers. Certainly if you're using a traditional file system type mounting approach, then EBS is the way to go, particularly if you combine it with the provisioned IOPS capability of EBS. This is where you can specify how many IOs per second you want the volume to support. We support currently up to 2,000 IOPS per volume, and of course you can RAID together multiple volumes. That said, if you have a distributed architecture where you can have multiple nodes running multiple threads, you can get tremendous bandwidth using S3. So I have a number of customers doing this for mapping type applications where they're moving large amounts of tiles. You can get very high performance in that particular use case using that approach. So there's a question about replication lag between multiple availability zones of AWS RDS. Now the example the person asked here is if the RDS master is in US East and the other one is in Tokyo. So as I mentioned before, the replication between availability zones for RDS is currently still between the same region. So you'd be replicating between availability zones in the same region. Typically those availability zones are single millisecond latency apart, so you don't notice it. As I mentioned, we're always interested in ideas, and clearly replicating across multiple regions for RDS is one that many people are interested in. Question here, currently my application session is stored in RDS. Can we use Elasticache instead? Probably in this case you might want to complement your use of RDS with Elasticache if you're finding that you have a performance issue or you want to make things go faster. That requires some code changes on your part, just interfacing of the Memcached session handler. There's a question here about what tools do you recommend for automating provisioning. So I'll cover that quickly. So there's a number of approaches you can take. Obviously you can just write your own scripts and have that run at boot time. You could pass them into the user data of the instance when you start. If you use CloudFormation, CloudFormation also supports the provisioning of software on instances as well. Then there are of course third-party tools like Chef, Puppet, RightScale, etc. that can also do that. It depends on how you'd like to deploy it. I've also got customers using Team Foundation Server, for example, to do that as well. Lots of combinations you can use. Question, is SQL Server RDS available for multi-availability zones? Not currently. Certainly it's something that a lot of customers have asked for, so we're endeavouring to get that happening as well. And we'll do a couple more questions. One question, very good question, what's the precautions about storing private data? As with any private data that you store, no matter where you store it, be it on your laptop, on premises, at home, in the cloud, if information is private, you need to put appropriate security controls around it. So this would be things like access controls, and also if it's very confidential, it should be encrypted as well. Encryption is a very powerful capability because it means you manage the keys. You may have also noticed recently an announcement where we've released a capability called Cloud HSM, which provides a hardware security module for storing keys in the cloud as well. This is useful for many people in these industries. I'll do one more question here. Let me just have a look. So the question was, if we have an auto-scaling feature of EC2 instances, why do we need load balancing? So these two features work together. They don't depend on one another, but they work together. Auto-scaling focuses on the ability to grow or shrink a farm of servers, so have a number of servers providing a service. The load balancing allows you to spread load across those servers. So it provides a common endpoint, a single endpoint at which your customers or other components of your application can point to, and then the load is distributed across that growing or shrinking farm. So they're very complementary components. So with that, we'll wrap up the webinar. At the end, you should get a pop-up that invites you to provide some feedback. Please do that. We'd really appreciate it. And, of course, you'll get your $25 voucher as a result of that. Also, I'd like to add, for anyone who asked a question that we didn't get to today, all the questions will be answered. The ones that weren't answered in real time today, we've got your email through your logon, and we'll come back to you and email those answers to you as well and be in touch. Thank you for your attendance. I hope you can join the future sessions as well.